Okay, 2012, number 6. Number 6, very often Maclaurin series problem. So let's see what they have cooking for us here. It looks like they've got function g has derivatives of all orders, and the Maclaurin series for g is this. Using the ratio test, determine the interval of convergence for this Maclaurin series. So the ratio test is we want to find what is the limit as n approaches infinity of the n plus 1 term. That would be, and remember we're doing absolute value, so you do not include the sign flipper in here. It's like the absolute value of this. So that would be x to the 2 times n plus 1 over 2 n plus 1 plus 3 divided by, or in other words multiplied by the n term, which is 2n plus 3 up here, and x to the 2n plus 1 down here. Alright, let's see if we can clean that up. This is 2n, that's a 2, so that's x to the 2n plus 3 up there, and this is x to 2n plus 1 here. So it looks like I've got an extra 2 x's up there, and then this is 2n plus 3 up here, and 2n plus 5 on the bottom. There's a couple extra x's, but those are not part of this n going to infinity, so I'm going to write that on the outside. And then I have here the limit as n approaches infinity of 2n plus 3 or 2n plus 5, and that is equal to x squared times this limit is just 1, because it's just the ratio of those coefficients. Okay, now what do we do with the ratio test? It's this, whatever you end up with here, that has to be between -1 and 1, right? So we say, so -1, right, and that gives us, that will be true for any x values between -1 and 1. Okay, but now we have to test the endpoints. At x equals -1, what does the series look like? They actually wrote out some terms, so that makes it a little easier to check. When x equals -1, we get the series -1/3 minus plus 1/5, right? Minus 1/7, etc. Yes, yes. And that's going to converge. So that's because it's alternating and terms are going to 0. And when x equals 1, or wait a minute, hold on a second. Is that true? When x equals -1, yeah, that would be negative, and then that cubed is negative. Yes, I think that is true. And then when x equals 1, it's just the opposite, right? So it still alternates. So that also converges because it alternates and the terms are going to 0. So that's the interval of convergence. That's probably worth a good chunk of points there. 3 or 4, I'd say at least, very least, it would be 3. The Maclaurin series for G is evaluated, and this is G, right? Yeah, this is the function for G. It's evaluated at x equals 1/2. It's an alternating series whose terms decrease in absolute value to 0. Hey, that means we can use the alternating series. The error bound is just the next term. So the approximation for G of 1/2 using the first 2 non-zero terms of this series is 17 over 20, over 120. I don't know why they're telling us all this stuff, because we could do that, right? I mean, if you plug in, that's 1/2 over 3, and then plug 1/2 into that, minus 1/2 cubed over 5. I'd make you do all that, right? And if you, apparently, that is equal to 17 over 120 if you know how to work with fractions. So they're sparing you that gruesome task. So they want to show that this approximation differs by the real thing by less than 1 over 200. Well, since the series is alternating and the terms are going to 0 and the absolute value of the terms is going to 0, the error bound is equal to the absolute value of the next term. And what's the next term? The next term is, we could call it the fifth term, or the fifth degree term. The next term is 1/2 to the fifth over 7. So you can't be off by more than that. And let's see, what's 1/2 to the fifth? That's 1 over 32 with the 7 on the bottom, right? Don't flip that 7 up to the top, Hannah. Remember that. And that would be 210 plus 14. That's 1 over 224, which is less than 120. Or 120. 1 over 200, excuse me. All right. And then last part. Write the first 3 non-zero terms and the general term of the Maclaurin series for the derivative of that. That sounds pretty easy. So the derivatives of those, the derivative of x over 3, or in other words 1/3 x, is just 1/3. The derivative of the next term is 3/5 x squared, right? Just taking basic derivatives here, plus 5/7 x to the 4th, ... There's the first 3 non-zero terms. The general term, there's a couple ways to do it, but probably the easiest one is just to take the derivative of this, right? So, in other words, just do the derivative rule with that. That would be, the exponent would come out to the front, so it would be 2n plus 1 over 2n plus 3. The negative 1 to the n, flip-flopper, is still going to be there. And then the exponent drops 1 times x to the 2n. That's it. All right? Just use your power rule on that. So 2n plus 1 over 2n plus 3. There's your sign flipper. X to the 2n, because we subtracted 1 from the exponent. And you can check to see if that works for these. If you plug in 0, then you get 0 over 0. Those turn into 0, so you get 1/3. Negative 1 to the 0 is 1, and x to the 0 is 1. So that gives you 1/3. We'll just check one more. If you plug in 2, you get 2 times 2. Sorry, if you plug in 1, we started with 0. If you plug in 1, you get 3 over 5. Negative 1 to the 1 would give you the negative sign, and x to the 2 times 1 gives you the 2. So, that was fun.